Good evening, guys. In the last session, we discussed about what is framework and how many types of frameworks available. So framework nothing but a semi-developed software which will provide some common logics, to help our developers to do more work in the less time. So here there are three types of frameworks available. One is front-end frameworks, second one is web frameworks, and the third one is ORM frameworks. Front-end frameworks are going to help us to develop user interface in the project. For example, Angular. Angular is one of the front-end framework. By using that Angular, we can develop user interface of the application. Similarly, in the backend, we will use web frameworks and ORM frameworks. Web frameworks are going to help us in developing web layer in the project. Web frameworks are going to help us in developing web layer in the project. For example, Struts is a web framework which got outdated. And we are having a ORM framework. ORM frameworks are going to help us in developing persistence layer of the project. For example, Hibernate is called as one ORM framework, which is going to help us in developing persistent layer of the project. Struts will help you to develop only web layer. Hibernate will help you to develop only data access layer, or we can call it as we can develop only persistence layer. Now, so at that time, there was no single framework which can help us in developing, both web logic as well as ORM logic. So that's where Spring framework came into picture. So to overcome the problems of the Struts framework, Spring framework came into picture. Spring framework is called as application development framework. By using Spring framework, we can develop end-to-end applications. Spring is called as application development framework. By using Spring framework, we can develop end-to-end application. Spring framework is free and it is open source framework, and Spring framework developed in modular fashion. Spring means collection of modules. So what are the modules we have in the Spring? There are several modules available in the Spring framework, like Spring Core module is available, Spring Context module is available, Spring JDBC module, Spring ORM, Spring AOP, Spring Web MVC, Spring Security, Spring Social, Spring Batch, Spring Data JPA, Spring REST, etc. Spring Cloud, Spring REST, Spring Cloud. Like that, there are several modules available in Spring framework. So Spring is very flexible framework, and Spring is not going to force you to use all the modules of the Spring. Spring is very flexible framework. It will not force to use all modules. Based on the requirement, we can pick up particular module, and we can use that particular module based on the requirement. It is not going to force to use all the modules. So whatever the module is required, you can pick up that particular module and you can use that module in your project. Spring is a versatile framework. It can be integrated with other frameworks easily. Suppose if you have Struts framework, Spring can be integrated with the Struts also easily. The current version of the Spring framework is 6.0. Spring framework is under license of VMware now. Okay, so you can check the official Spring www.spring.io. So we can go to this spring.io website. We can see the documentation of the Spring, and we can see what we can do by using Spring framework. Okay, now Spring is developed in modular fashion. There are several modules available in the Spring framework. Okay, guys, now here let us see. First one, what is the purpose of Spring Core module? Spring Core, it is base module in the Spring framework. If you want to work with any other module, then if you want to work with any module in the Spring, then the first thing that we need to understand is Spring Core. What is a Spring Core? It is base module in the Spring framework. This module is providing fundamental concepts of the Spring. Spring Core module providing fundamental concepts. The main advantage of going for Spring, that is dependency injection. Spring core module providing fundamental concepts of Spring framework. So what are those fundamental concepts? One is IOC container, that is inversion of control. IOC container, that is inversion of control. And the second one is dependency injection. Dependency injection. Bean life cycle, bean scopes, bean life cycle, bean scopes, auto wiring, etc. So these are fundamental concepts of the Spring framework. So here Spring core, it is base module in the Spring framework. Spring core module providing fundamental concepts of the Spring framework, like how to work with IOC container, what is IOC container in the Spring framework, what is the dependency injection in the Spring, what is the Spring bean life cycle, what is bean scope, what is auto wiring. Such kind of the fundamental concepts are providing by Spring core module. Okay guys, so if you want to start learning Spring framework, or if you want to learn Spring Boot, the first we need to start is Spring core. Without having the knowledge on the Spring core module, we cannot become a Spring developer, we cannot become Spring Boot developer. To work with the Spring or Spring Boot, Spring core knowledge is mandatory. Spring core module is base module in the Spring framework. This is Spring core module providing fundamental concepts of Spring framework, like IOC container, dependency injection, bean life cycle, bean scopes, and auto wiring, etc. Like that, there are so many concepts are available. Now, second one is Spring context module. So what is this Spring context module? It will provide configurations required for our Spring based applications. It will deal with configurations required for our Spring applications. When we are working with our application, some configurations we need to do. The configuration management we are going to take care with the help of Spring context. Core module is providing fundamental concepts of the Spring framework. Spring context will deal with configurations required for our Spring application. Configurations required for the Spring application. And the next one, we are having Spring AOP module. AOP stands for Aspect Oriented Programming. AOP stands for Aspect Oriented Programming. What is the main purpose of going for this AOP module, right? Core module is providing fundamental concepts of the Spring. Context module is dealing with configurations required for the Spring application. AOP stands for Aspect Oriented Programming. AOP is used to separate primary business logic and secondary logics. AOP is used to separate business logic and secondary logic. Okay, so what is the meaning of secondary logic? For example, in our project, security will be available. In our project, logging will be available. In our project, transactions will be available. In our project, auditing will be available. In our project, exception handling will be available. So such a kind of logics, we should not write directly in our programs. So we need to separate these logics. These common logics are called as secondary logics, are going to separate. When I'm writing a method, in that method, I will write some business logic. Along with that business logic, I need to implement some security. I need to implement some logging, some transactions, auditing, exception handling. So instead of writing everything in the single method, we are going to separate business logic and secondary logics. So we use AOP to separate business logics and secondary logics in the project. So what is the advantage if you separate the business logic and secondary logic? Easily we can maintain, easily we can modify any logic in the future, right? So now, if you take an example, for example, I'm taking one method. Assume that I'm writing one method here, public void amount transfer or public boolean amount transfer. Okay, here I'm taking double amount, okay, long from account and long to account. So like this, I'm writing one method in order to transfer the money. So here logic to transfer. Only this logic is not sufficient. Along with this logic, I need to write some security. I need to write some auditing. I need to write some security. I need to write some auditing. Like that, we need to write several logics along with the business logic. We need to write several logics along with the business logic. Security is required, auditing is required, logic to transfer is required, and transaction is required. Transaction is also required. So now here, along with the business logic, there are some secondary logics also available. It is not recommended to combine business logic and secondary logic. Only this is my business logic to transfer. What about the security? What about auditing? What about the transaction? These logics are called as our secondary logics. These logics are called as our secondary logics. If I combine my business logic and secondary logic, it is maintenance problem. Tomorrow, I want to change security technique in my project. How many places you will change? How many methods will be available in the project? I want to change my transaction logic in the project. How many places you will change? There are n number of methods in the project. In every method, if you write the business logic, security logic, auditing logic, transaction logic, it will be difficult to manage this code in future. If I want to make some changes to the code in the future, if I change the business logic, then my secondary logic may affect. If I change the secondary logic, then my business logic may affect. So that's why it is not at all recommended to combine primary logics and secondary logics. Okay, so what are the secondary logics here? Security and auditing. I will keep them in a separate component. Transaction, I will keep that in a separate component. Okay, my method will have only business logic. Secondary logics I'm going to keep in the separate components. So this is called aspect-oriented programming. So earlier we used it to write everything in the single method. Everything we are going to use in the single method. Business logic, transaction logic, security logic, auditing logic, etc. Right? Security, logging, transaction, auditing, exception handling. These logics are called as secondary logics. Transferring the amount from one account to another account is the business logic. So if you combine business logics and secondary logics, then what is the problem? Guys, if I combine business logic and secondary logic, then what is the problem? Maintenance problem. AOP is used to separate business logic and secondary logics in the project. Logging, security, transaction, auditing, exception handling, these all are comes under secondary logic. So what maintenance problem will come? If we combine business logic, if we combine business logics and the secondary logics, then we will face maintenance issues of our project. Are you guys getting my point? So if you combine primary logics and business logics in the project like this, assume that everything I'm writing in the single method. If I write everything in the single method, what is the problem? Tomorrow, if I change the business logic, there may be effect on the secondary logic. If I change the secondary logic, there may be effect on the business logic. My code is tightly coupled. Okay, guys. So in order to avoid this problem, we are going for AOP. What is AOP? AOP stands for aspect-oriented programming. AOP is used to separate business logics and secondary logics in the project. So what are the secondary logics? Security, logging, transaction, auditing, exception handling. These logics comes under secondary logic. Now in my method, I have secondary logic and business logic. Like this, in my project, there are 1000 methods available. Amount to transfer, okay, debit, credit, loan, home loan, personal loan, house loan, ATM transaction, net banking, check balance, download statement, download mini statement, download major statement, apply for the loan, change the mobile number, change the email ID, change the password, sign up, login, forgot password. N number of functionalities are available in the project. So N number of methods will be available in the project. In every method, business logic will be available. Along with the business logic, I need some secondary logics also. If I combine the business logic and secondary logic, then we are going to face maintenance problem. So to avoid that, what we are going to do? we are not going to combine the primary logic and secondary logic in the project. We are going to separate the primary logic and secondary logic. How to separate the primary logic and secondary logic in the project? To separate the primary logic and secondary logic in the project, we are going for AOP. AOP stands for aspect oriented programming. What is the main aim of the AOP? To separate the business logic and secondary logic in the project. Are you guys clear? Spring Core module. Spring Core is the base module in the Spring framework. Spring Core module providing fundamental concepts of the Spring like IOC container, dependency injection. Why we are mainly using Spring? Because of this IOC container and dependency injection. IOC container, dependency injection, bean lifecycle, bean scope, auto wiring, all these concepts are providing by Spring Core module. Then what about Spring Context? Spring Context will deal with configurations required for our Spring applications. Then what is AOP? AOP stands for aspect oriented programming. It is used to separate business logics and secondary logics in the project. Next one, Spring JDBC. What is Spring JDBC? Spring JDBC is used to simplify database communication logic. Right. Sir, already JDBC is available now. Then why we need to go for Spring JDBC? So if you go for in the JDBC, we need to write the boilerplate code. In Java JDBC, we need to write boilerplate code. Load driver, get connection, create statement, execute query, close connection. Okay, so these are repeated lines of code we need to write in every method. Loading the driver, getting the connection, creating the statement, executing the query, closing the connection. These are common requirements for every JDBC program. Okay, so in my project, I want to perform operations with the database from multiple screens. So in every Java class, we need to write the logic to load the driver, get the connection, create the statement, execute the query, and close the connection. So these are very common requirements that we need to do in every project. How many places you will write this? How many places you need to write this logic? In several places. Load the driver, get the connection, create the statement, execute query, close the connection. In JDBC, we need to write boilerplate code. What is the boilerplate code? Boilerplate code is repeated code. In Spring JDBC, we no need to write the boilerplate code. In Spring JDBC, we can execute the query directly. Remaining thing will be taken care by Spring JDBC. If I want to communicate with the database by using JDBC, then I need to load the driver. I need to get the connection. I need to create the statement. I need to execute the query. I need to close the connection. So we need to do all this stuff. When we go for Java JDBC. Using Spring JDBC, we can directly execute the query. Okay. What about the driver, connection, statement, closing connection and all? You directly execute the query by using Spring JDBC. Whatever the boilerplate code is required, Spring JDBC will take care of that. You no need to open the connection. You no need to create the statement. You no need to close the connection because those are common steps that are required for every Java programming. Using Spring JDBC, we can directly execute the query. The remaining logics, the remaining part, Spring JDBC will take care. The remaining parts, Spring JDBC will take care. That means opening the connections, closing the connections, all that stuff will be taken care by Spring JDBC. So we can save our time by using Spring JDBC. If you go for normal JDBC, lot of boilerplate code we need to write. So in every program, we need to load the driver, we need to get the connection, we need to create the statement, we need to execute the query, we need to close the connection. So lot of boilerplate code we need to do. Let me show you. So in the evening, I'm taking one advanced Java class. I will show you the problem with that JDBC. So if you go for that advanced JDBC, normal Java JDBC concept, how many lines of code I'm writing daily to interact with the database? Let me show you. We need to load the driver. We need to get the connection. We need to create the statement. We need to execute the query, and we need to close the connection. We need to close the connection. Yeah, see here. I want to insert one record into table. Okay, then what I'm doing, I'm loading the driver. I'm creating a connection. I'm creating a statement. I'm executing the query. I'm processing the data. I'm closing the connection. Now I want to insert the book. Here also same. I need to load the driver. I need to get the connection, create the statement, execute the query, close the connection. I want to retrieve the records. Same story. Get the connection, create the query, execute the query, and close the connection. Here also same story. Same story. Load the driver, get the connection, execute the query, close the connection. So can I say in one project at 4 places I am writing the same logic? That is called boilerplate code. So if you're writing same code in multiple classes, okay guys, if you write same code in multiple classes, that is called boilerplate code. That is also called as repeated code. So if you go for normal Java JDBC, we need to write boilerplate code like below in several classes. Okay, in Java JDBC, we need to write the boilerplate code in several classes, loading the driver, getting the connection, creating the statement, executing the query, closing the connection. Using Spring JDBC, we can directly execute the query. The remaining part Spring JDBC will take care. That's it. That means we can do more work in the less time. Loading the driver, getting the connection, creating the statement, closing the connection is common for everybody. Query will change from requirement to requirement. So that's why you just take care of the query execution. You just take care of the query. Remaining part will be provided by Spring JDBC. Are you guys understanding the point? What is the Spring Core? What is the Spring Context? What is the Spring AOP? What is Spring JDBC? Are you guys getting my point? Yeah. What is the purpose of a core? Spring Core is providing fundamental concepts of the Spring framework, mainly IOC container, dependency injection, bean lifecycle, bean scopes, auto wiring. Context module will deal with configurations required for our Spring applications. AOP means aspect oriented programming. AOP is used to separate business logics and secondary logics in the project. If we combine business logics and secondary logics, then we will face maintenance issues of our project. Spring JDBC is used to simplify database communication logic. In Java JDBC, we need to write a lot of boilerplate code. If you go for JDBC with Spring, we need to take care of only query execution. Remaining part will be taken care by Spring JDBC. And the next one, we have Spring WebMVC module. Spring WebMVC module. It is used to develop web applications and RESTful services. It is used to develop both web applications and distributed applications. It is used to develop both web applications and distributed applications. Sir, what is the meaning of web application and distributed application? Web applications are used for customer to business communication, C2B, like Gmail. Gmail is a web application. So web applications are used for C2B communication, customer to business communication. Then what about a distributed application? Distributed applications, nothing but they are used for B2B, that nothing but business to business communication. So for the web application, Gmail is one example. Gmail.com, Facebook.com, etc. These all are the web applications. Then what about the distributed application? IRCTC with the Make My Trip communication. IRCTC will communicate with Make My Trip application. Our passport application will communicate with the Aadhaar application. Okay, passport application will communicate with our Aadhaar application. So if one application is communicating with another application, then those applications are called as distributed application. Web applications are used for customer to business communication, which is called as C2B communication. Distributed applications are used for B2B communication. That means one application will communicate with another application when we go for distributed. Okay, so Spring Web MVC, it is used to develop both web applications and distributed applications. Web application means C2B communication, nothing but customer to business communication. Distributed application means B2B, so we can also call them as web services. Okay guys, distributed applications, nothing but web services or RESTful services. Okay, by using this Spring Web MVC module, we can develop web applications and we can develop RESTful services also. Okay. Okay guys, so we can develop web applications and we can develop distributed applications also by using this Spring Web MVC. By using this Spring Web MVC, we can develop both web applications and distributed applications also. Web applications means C2B communication, distributed applications means B2B communication will be available. If you want to develop any web application or if you want to develop any REST API or SOAP web services, we can go for Spring Web MVC module. To develop web applications, we'll go for Web MVC. To develop the persistence logic, we will go for Spring JDBC. To deal with primary logics and secondary logics in the project, we will go for aspect-oriented programming. To deal with the configurations in the Spring applications, we'll go for Spring Context module. So to deal with IOC container and dependency injections, we'll go for Core module. And similarly, here guys, we are having another module in the Spring, that is Spring ORM. There is another module called Spring ORM module is available. So what is the purpose of Spring ORM? Okay, Spring ORM. ORM nothing but object relational mapping. ORM nothing but object relational mapping. Spring framework is having integration with ORM frameworks available in the market. Spring framework having integration with ORM frameworks. Example, Spring ORM, Spring ORM, Spring Data, Spring ORM, Spring Data, JPA, etc. If you want to develop your persistence layer by using object relational mapping principles, then you can go for Spring ORM. Here guys, JDBC will represent the data in the text format, whereas ORM frameworks will represent the data in the object format. Okay, JDBC will represent everything in the text format, insert into query, retrieve the data in the result set format. Okay, so in the JDBC, we are going to represent the data as a text format, whereas in the ORM, we are going to represent the data in the form of objects. Okay, so how can I work with the Hibernate using Spring? Spring with the Hibernate combination is there. Okay, Spring framework having integration with the ORM framework. So Spring ORM you can use, Spring Data JPA we can use to develop our persistence layer with the ORM principles. Okay, remember. So JDBC will represent data. JDBC will represent data in text format, whereas Hibernate ORM will represent data in objects format. Okay guys, so JDBC will represent the data in the text format, whereas Hibernate ORM will represent data in the object format. Spring ORM is available and Hibernate ORM, Spring ORM is available. Sir, then what is the difference between Spring ORM and Hibernate ORM? There is no difference guys. Actually, here Spring people implemented a concept called use the same functionality without reinventing the wheel. Use the same functionality without reinventing the wheel. Okay, so that means instead of redeveloping a separate concept, let us use the existing functionality. Instead of reinventing the wheel, let us use the existing functionality. Already Hibernate framework is super success in the market for ORM. Already Hibernate framework is super success in the market for ORM. So what Spring people thought is, why we need to develop a separate ORM? Why can't we use a Hibernate in the Spring? That's where they integrated Hibernate in the Spring, that is called as Spring with the Hibernate, Spring ORM. So here they did not develop anything new in the Spring ORM. Whatever is already available, they just reused it. Instead of reinventing the wheel, they just reused that functionality. Instead of reinventing the wheel, they just reused it. So that is called Spring ORM. So whatever the Hibernate is available, Spring people using that existing Hibernate using Spring ORM concept. Okay, so Spring ORM provided some classes to work with Hibernate easily. To avoid the boilerplate code in Hibernate, Spring Framework provided Spring ORM with some ready-made classes and ready-made methods provided by Spring ORM. Okay, guys. And the next one is Spring Security. Spring Security. Security is the most important concept for every project, right? Securing the application is the most important part for every project. Okay, Spring Security. So security is the most important part for every application. Security is very crucial. Security is very crucial for every application. Okay, for every application. By using Spring Security, we can implement authentication and authorization for our application. Using Spring Security, we can implement both authentication and authorization. We can implement authentication and authorization. Can you guys tell me what is the difference between authentication and authorization, guys? Can you guys tell me what is the difference between authentication and authorization? Can you guys tell me what is the difference between authentication and authorization? Any idea? Any idea on the difference between authentication and authorization? Guys, come on. Any idea on the authentication and authorization? Come on, guys. Any idea on the authentication and authorization? Authentication means checking the username and password is correct or not. Can this user log in into our application or not? That is called authentication. Can user access this functionality in the project or not? That is called authorization. So for the project, we need both authentication and authorization. Spring Security provided authentication and authorization implementations for our projects. So Spring Security, OAuth integration, Spring Security with OAuth 2.0, that is most famous security technique currently in the market. OAuth 2.0, Spring Security with JWT. Spring Security with JWT depends upon the requirement. We can go for OAuth authentication or JWT authentication. Nowadays in the market, all the applications are getting secured using this OAuth and JWT only. We are implementing security for our applications by using either OAuth or JWT. So if you want to secure your Spring based applications, then you can use Spring Security with the JWT. JWT stands for JSON Web Tokens. JWT stands for JSON Web Tokens. Spring Security with OAuth 2.0. And using Spring Security, we can implement authentication and authorization. Security is very crucial for every application. So Spring Security module is providing that authentication and authorization implementations. And similarly, we are having Spring Batch. We are having Spring Batch. So Spring Batch means bulk operation. Batch means bulk operation. Okay, I have some records in the Excel. I want to read the data from the Excel sheet. I want to store into database table. That can be implemented by using Spring Batch. Okay, batch means bulk operation, reading data from Excel and store it into database table. Read the data from Excel file and store that into database table. Okay, that can be one batch operation. Send monthly statements to customers in email. It is a batch operation. Send bulk SMS regarding reminder. Send reminders to customers as bulk SMS. Okay, so if you want to perform same operation with multiple records, then that is called as a batch operation. In order to do such kind of a batch operation, we are having a concept called Spring Batch. Batch means bulk operation. Reading data from Excel file, storing into database table, sending monthly statements to customers in email, sending reminders to customers as a bulk SMS. All these things comes under batch. Security is very crucial part. Authentication, authorization, we can understand with the security. With OAuth integration, JWT integration, we are going to understand that security. JDBC will represent data in the text format, whereas Hibernate ORM will represent the data in the objects format. Okay, JDBC will represent data in the text format, whereas Hibernate ORM will represent the data in the object format. WebMVC is used to develop web applications as well as distributed applications. JDBC to simplify database communication logic. AOP to separate business logic and secondary logic. Context to deal with the configurations required for our application. Core module will deal with the fundamental concepts of the Spring. Fundamental concepts of the Spring framework. And similarly, we are having Spring Cloud. It provides service registry to register microservices. It provides load balancing. It provides load balancer to balance load of our application. It provides load balancer to balance load of our application. It provides monitoring capability. It provides monitoring facility. So when we are developing our application as a microservices architecture, we need some cloud related concepts here, right? So those things we are providing by our Spring Cloud. It provides service registry, gateway. Okay, it provides some tools for the developers to quickly build the common patterns in the distributed system. It provides some common tools. To quickly build distributed systems. Okay, distributed systems, nothing but we are going to develop several REST APIs as a microservices. It provides service registry to register all our microservices. It provides API gateway. It provides API gateway to have single entry point for all our APIs. All our APIs. It provides load balancer to balance load of our application. It provides monitoring capability or monitoring facility. That is Spring Cloud. Spring Cloud is providing some common tools to quickly build distributed systems. It is providing some common tools to build our Spring applications easily. Okay, distributed configuration, service registration, load balancing, and it provides monitoring facility. It provides circuit breaker. Circuit breaker means it is used to implement fault tolerant systems. Fault tolerant systems can be developed by using this, and it is providing distributed tracking. Distributed messaging is also available. Distributed messaging part is available in the Spring Cloud, and it is providing routing concept also. So from the front end, requests are coming. Those requests I want to route to my backend applications. That routing concept also will be provided by Spring Cloud. For developing our application by using microservices architecture, this Spring Cloud concepts are very, very important. Spring Cloud provides some common tools for quickly building our distributed systems. Okay, guys. What is the purpose of Spring Cloud? Spring Cloud is providing some common tools for quickly building our distributed systems. So it provides service registry to register all our microservices at one place. So in my project, 20 microservices are available. I want to see all the microservices at one place. Okay, for that we can go for service registry, which is given by Spring Cloud. For all our microservices, I want to have a single entry point. I don't want to write the security in each and every microservice. I will write the security at one microservice and I will give the entry point for our application as that security point. API gateway. So single entry point, single door will be available to access our APIs in the project. And it is providing load balancer. So when the load is increasing on the project, I want to balance that load. Okay, so it provides load balancer concept. Too many people, so many requests are accessing. So many people are accessing our application. And my servers are not able to handle that load. Then we are going to monitor that load and we are going to implement load balancer to distribute the load. Okay, guys. So load balancers also will be provided by Spring Cloud. Load balancer means it is used to distribute the load to multiple servers. It is used to distribute the load to multiple servers. Circuit breaker. When some functionality is not working, I don't want to send error response to the client. I want to go for fault tolerant systems. So which are also called as resilience systems. Currently in the market, we are going for resilience systems development. I want to develop resilience system. That means if something is wrong in my code, I don't want to send the error response to the client. If something is wrong, I don't want to send error response to the client. So I want to execute some alternate code. Suppose if M1 is failed, I don't want to send error response to the client. I want to access some other logic as a backup logic, fault tolerance. That can be implemented by using circuit breaker in the Spring. So the circuit breaker concept is available as part of our Spring Cloud. Spring Cloud is one of the most important part in our course. As we are going to understand how to build the microservices, to build that microservices, Spring Cloud concepts are required. Service registry, API gateway, load balancer, monitoring, circuit breaker, distributed messaging, and routing. These topics are very, very important for us. These concepts are very, very important for us. Are you guys clear? Are you guys clear with my point? Yeah. What is the purpose of Spring Cloud? It is providing some common tools. In order to develop our microservice based applications. It is providing some common tools in order to develop our microservices based applications. And similarly, we are having one more important module, that is a Spring Test. Spring Test module is available. It provides unit test framework. Whenever we develop some application, whether that code is working as expected or not, we need to test it. So for that, unit testing we are going to implement with the JUnit and mocking. So it is providing that a test framework. By using this test framework given by the Spring, we can implement unit testing that is required for our project. Like JUnits we can implement. Like JUnits we are going to implement for our application. So a test framework is providing unit test framework. That means some set of classes and methods it is providing, annotations it is providing to simplify unit testing of our application. By using Spring Test framework, we can implement unit test required for our application. Spring Cloud, we are going to understand the Spring Cloud in the microservices, guys. In our course, Spring Cloud is available. Now you may not understand what is that routing, what is API gateway, what is service registry. So today session is not for this. Today you need to remember that cloud is providing some tools to build our distributed systems. When we start the microservices, at that time you are going to learn what is a service registry, what is API gateway, what is load balancer, what is monitoring, what is circuit breaker, what is messaging, what is routing. All these things we are going to understand in the microservices. Okay, fine. Spring batch. Batch means performing the bulk operation. Security, to secure our application. Security is very crucial for every project. ORM for object relational mapping, and WebMVC to develop both web applications and distributed applications. JDBC, it is used to simplify database communication logic. Okay, and AOP, that is used for aspect oriented programming. To separate the primary logic and secondary logics, we are going to use this Spring AOP. Are you guys clear with my point? Context, to deal with the configurations. Core module, which is going to deal with IOC container and dependency injections in our project. IOC container, which is used to have dependency injections. Come on, guys. Now you got the clarity, what modules are available and what is the purpose of these modules. Understood. So we got the basic clarity on what are the modules available and what is the purpose of the modules available. What is the module and what is the purpose of the module, we understood. So from tomorrow, we are going to start with the Spring Core module. Spring Core module is the base module in the Spring framework. That module is providing fundamental concepts like IOC container, dependency injection, bean lifecycle, bean scopes, auto wiring. Without understanding these concepts, we cannot start with the Spring Boot. Our course is Spring Boot and microservices, right? So to understand Spring Boot and microservices, Spring Core module we have to learn. So once we complete the Spring Core module, then we are going to start with our Spring Boot. Are you guys clear with my point? Yeah, good. Thank you, guys. I'm going to upload these class notes to our website. So the people who enrolled for the course, they have access in the portal. You can just log in into our portal. You can download these class notes. So I'm going to upload these notes, introduction notes. I will just upload the same record with the new file. Let me go to this. So our course code is 27 SBMS. Yeah, so this is the class notes file. Today's notes I have updated in the portal. Guys, all of you, please confirm, are you able to access the notes? All of you, are you able to access the notes? Could you please let me know? Check that in the website and let me know in the chat box. Are you able to access? Yes, sir. Good. Thank you. Thank you, guys. So tomorrow we'll continue. Tomorrow we'll start with the Spring Core module.